Review the question patterns for APSC. All right, so let me just arrange this. So if you can see from geography, this is 2024, we got 7 questions. So please go through the these topics as well. All right, warm ocean currents, okay, the name of warm ocean currents and all those things. So please go through this once. Then we see in 2023 4 questions. Okay, so on an average we are getting 5-6 questions from geography on an average. All right, and most of them are related to current affairs. If something is going on in the world, like what is El Nino, La Nina, all those, this time is very important. Then sea level rises. So geography, like I said, it will be based on concepts. It will not be based on your what you call it, direct static questions, but the concepts are static, but the questions will not be like direct. It will be conceptualized a little bit. Okay, so we will do some important concepts for this year. The first one is this concept of ENSO. Okay, that is La Nina and your El Nino. Can anyone tell me what is the full form of ENSO? ENSO. Did you get this word? Concept of ENSO. Anyone? No? So ENSO refers to El Nino Southern Oscillation. All right, El Nino Southern Oscillation. Okay, the first thing you have to remember is where does it takes place. Okay, can anyone tell me where does it take place? The beginning of El Nino.
The Pacific Ocean.
Yeah. So Pacific Ocean is the location of ENSO. Okay, it stands for El Nino and Southern Oscillation. All right, and this phenomena takes place in the Pacific Ocean. So if you look in the world map, if you have your atlas or your globe, you'll see this Pacific Ocean is one of, like it's a big sea mass between two continents, right? Between two, your Americas and your Asia, Oceania continent, right? So it's a vast area of water, right? That is where we have this ENSO, okay? El Nino and La Nina. ENSO, oscillation. Can anyone tell me what does oscillation means?
Movement.
Yes, movement, or like seesaw. Okay, if you have seen a seesaw, so sometimes one goes down, then the other one goes up, so that is oscillation. Okay, it can also mean like pendulum, all right, swinging from one place to another, right? So this oscillation takes place in your Pacific Ocean. Oscillation of what? Particularly water, water current. Okay, one is warm current and the other one is cold water current. All right, that is the oscillation they are talking about. So ENSO refers to El Nino Southern Oscillation. It happens in the south of equator most of the time, or around the equator. That is why it is called the Southern Oscillation. All right, so we know few things from ENSO. El Nino, okay, which we'll discuss. Southern Oscillation means the transfer of the currents from one place to another. Okay, from warm current goes to other side, and cold current comes to that side. So this penduluming of your, or swinging of the currents, ocean currents, is referred to oscillation, and it's called southern because it happens below the equator, okay, in the southern hemisphere. All right, So that is ENSO. So in normal condition, okay, in normal condition, what happens is, so this side on my on the screen, if you can see this side, sorry, yeah, so this side on the right refers to your the Americas, okay, this is the America, Southern America, all right, and this is your Australia and Southeast Asia and all those, like, you know, Indonesia, all those areas. Australia is this one, all right. So in normal condition, what happens is this wind, okay, this wind, this wind, red color winds are called the trade winds, okay, or easterlies, okay, easterlies or trade winds, all right. So during normal condition, when the year is normal, this trade winds blows from east to west, okay, this is east, this is west. East is your Southern America part, and this is the eastern part. So this is Pacific Ocean. So from the east of Pacific, this trade winds blows towards the western, okay. Now in this area, in the middle of Pacific Ocean, there's a lot of warm water, okay, a lot of warm surface water. So these trade winds push this surface warm water towards the western side. So this red color, you can see the warm water. So over the time, over a period of 1-2 months, this warm water moves towards the western side of the Pacific, okay, because of which the warm water from the eastern side goes to the western side, and the underneath the cold water comes up in the eastern side. That is called upwelling. When cold water from the bottom comes up, okay, that is called upwelling, all right. And this direction, okay, this incline, when warm water is on one side and the cold water is on the other side, this incline is called thermocline, okay, thermocline, all right. So this trade winds blows from east to west in normal condition, bringing warm water to the western side of Pacific. Because we know this side is already you know, face a little bit of warm area, right, this side is warm. So what happens is, when it reaches the western side, the warm air, okay, carried by the trade winds, okay, rises up, and because of convection we get rain in this area, okay, we get this rain, okay, in this area, in Australia, Indonesia part, all right. And after this warm air again goes up, it cools, and this cool air goes towards the eastern side of Pacific, cooling South America and all this Andes and all those areas, all right, in the Peruvian coast, it cools the Peruvian coast, right. So this is a normal condition. Any confusion?
No, sir.
Okay, so normal condition, remember, trade winds blows from east to west, goes to the western side of Pacific, where it gives rain because of convection, because warm air rises up into the air, forms clouds, and it starts raining in the western Pacific towards Australia and all these areas, okay, bringing rain to those areas. Then this air goes up again, becomes cool, and this cool air is provided in the South Americas, all right. That is normal condition. In El Nino condition, what happens is, okay, what happens is, the problem here is very simple, okay. This side also is hot, we know. This side also, over the summers it has become hot. So in El Nino condition, this warm air, these trade winds are not very strong, okay. These trade winds are not very strong, okay. The weakening of trade winds means this warm air rises up, okay, and from this side also warm air comes and rises up, and most of the rain happens in the middle of Pacific Ocean, okay, middle of Pacific Ocean, right. And because of this, from the western side, when the air goes up, okay, when the air goes up, it comes, cools down, and brings drier air in the western side, okay. And same here, the cool air goes there, but the current, water current, is stagnant, it's not moving, okay. The warm surface temperature water is not moving, It is in this Pacific Ocean. So this, because of this warm current pressure, warm water present, okay, what happens is, because the trade winds are not strong, so this warm water slowly and slowly moves towards the eastern side. Okay, it moves slowly and slowly towards the eastern side, and during winters this area becomes hot. Okay, that is southern America's Peruvian coast becomes hot. All right, that is the condition of El Nino. Okay, anyone did not understand? So what is the normal condition in this southern oscillation? In normal condition, what happens? Prince Rongchan, please explain.
Sir, sir, পেচিফিকৰ বতাহটো ইষ্টৰ ফালে যায়, সেইটো পোল কাৰেণ্টটো ওৱান কাৰেণ্ট ফালে যায়, তাৰপিছত তাতে এনেকে ৰেইনবোৰ হয়। কিন্তু ইফ যদি এল নিনো হয় তেতিয়াহ'লে দুটাৰে ইফালে অভাৰ দ্য টাইম পেচিফিক অ'চেনৰ ৱাৰ্মনেছটো বাঢ়ি যায়, আৰু ইফালে ইষ্টতো ৱাৰ্ম হৈ থাকে। তো যেতিয়া দুইফালৰ পৰা ৱাৰ্ম এয়াৰটো আহে তেতিয়া মাজতে ৰেইনটো হয়, কিন্তু কাৰণ দুটা জায়গাতে ড্ৰাই উইন্ডছবোৰ থাকি যায়।
Harlongbi, please correct Prince Rongchan.
Sir, in a normal condition, sir.
Yeah, any normal condition?
Yes, sir. In normal conditions, the winds, the hot winds, when it pushes towards the warm currents towards the western side, sir. So the winds move from east to west, called easterlies. So the warm current, it pushes to the coast of the Asian continent, and thus the warm air rises up. So it causes rainfall in the Asian continent, sir.
Okay.
Not in the middle of the ocean.
Okay. So you have to remember one thing. This this ENSO or this El Nino activity occurs mostly in the winters, for in the Christmas time. All right, during the Christmas. That's how it gets the name also. Okay, when it becomes hot in Peruvian coast during El Nino, so the Peruvian fishermen said this is El Nino, meaning the boy. Okay, referring to the Jesus. All right, so they have a song also, El Nino di Savidad. Okay, so something like that. So El Nino comes from a Spanish word meaning the little boy. Okay, then during Christmas or during the winter period, when the Peruvian people found that it is warm this time, so they called it El Nino. Okay, the little boy, referring to Christian faith. However, that is not important. What the context is, during winters, okay, in Christmas time, around Christmas time, the the easterlies, okay, that is rising, the trade winds that is rising from the southern coast of South America, western side of South Americas, it blows towards the west coast of the Pacific, that is your Australia and Oceania, normal conditions. Okay, so they bring in the warm air of the summer, they bring in the sea is warm because of the summer activities and all those, so the warm current goes towards the western side of the Pacific, and because of that, the warm air rises up and causes heavy rainfall in Oceania, particularly east coast of your Australia and all those Southeast Asia parts. All right, so we get rain during that time in Southeast Asia also. Okay, particularly Australia and all those areas. So in Australia it is summer, by the way. When we say we have winter, they are going through summer, by the way. Okay, because of the oscillation of the southern winds. All right, so these winds bring rain to Australia. Okay, in El Nino condition, what happens is the the easterlies, they are not present very strongly. Okay, because of the warming, too much warming. So the warm current is mostly stagnant, it does not move so much. Okay, and over the time, the warm current from Australia also slowly penetrates inside the South Americas, and because of that, you get a warm winter in Peruvian coast or in South America. Okay, that is called El Nino. It warms up the Pacific Ocean. So El Nino refers to warm current. Remember that. El Nino refers to warm current. All right, fine. Then in La Nina condition, okay, in La Nina condition, if you can see, it is normal condition, but with increased trade winds. Yeah. Huh?
বলব বুজি নাপালো স্যার মানে নর্মাল কন্ডিশনত তো স্যার ইস্টার্লিস হৈ কেন উইন্ড টু যায় ন স্যার
Why they're called easterlies is because they originate from the east of Pacific. That's why. From east to west it moves. Okay, in normal condition, the trade winds. That's why they are called as easterlies. Okay.
স্যার বিকজ অফ দ্যাট তাতে মানে এছিয়াত ৰেইনফলটো হয় বাট স্যাৰ এল নিনোত তো স্যাৰ আপুনি ক'লে কি হেৰি পেচিফিক অচনটো ৱাৰ্ম হৈ যায় ন স্যাৰ ওভাৰ দ্য টাইম
Yeah, because the easterlies are not strong. The winds are not strong. So they don't move so much. Okay? They don't move so much.
So easterlies are not strong because of like sir warm current দুইফালৰ পৰা হৈ মানে দুইফালে warm current হৈ আছে কাৰণে নেকি স্যাৰ
নহয়, because of গৰম, বেছি গৰম হলে হাৱাটো ওপৰতে যাব না।
স্যাৰ
When you have less winter, what happens? It's more hot, right? So the air will always go up, right? So because of global conditioning, or because if the winters in the Arctic is not very strong, okay, so that time these winds cannot move. Okay, winds cannot move so much, so winds have to come from somewhere. No, it is circulating all around the globe, and depending on the temperature of the earth, the winds move also. Okay.
আচ্ছা স্যার মানে যেটা পেসিফিক ওশনটো ঠান্ডা হৈ থাকে তাতে হাই প্ৰেছাৰ হৈ থাকে আৰু এছিয়াত কাৰণে লো প্ৰেছাৰ হৈ থাকে তাৰ কাৰণে ইষ্টাৰ্লিছ ফ্লো হয় তাৰ কাৰণে এছিয়াত ৰেইনফলটো বাট যেতিয়া এল নিনো আহে পেচিফিক ওচনটো ওভাৰ টাইম গৰম হৈ যোৱাৰ কাৰণে দুইফালেও লো প্ৰেছাৰ হৈ থাকে তাৰ কাৰণে উইণ্ডটো ডাইৰেক্ট ওপৰত উঠি যায় তাৰ কাৰণে ৰেইনফলটো নহয় নেকি স্যাৰ কাৰণ বেছি হিট হয়
You're right. It is correct.
ওকে স্যাৰ
Okay, so the warm current does not move to the west. It becomes mostly stagnant, so it does not move. Even the winds are not very strong. So because of that, we see warming of the Peruvian coast. Okay, that is El Nino condition. All right, El Nino condition. Now we go to La Nina. In La Nina, very simply, it is normal condition but with increased trade winds activities. Okay, increased trade wind activities. And because of this trade winds going there so in high number, we get heavy rainfall in these areas. Okay, we get heavy rainfall in these areas. All right, and we on the other side we see a very cool weather because the cool air goes back again. Okay, fine. This is the cycle of trade winds. Okay, this is the cycle of trade winds. All right. It goes. That is why it is called southern oscillation. Okay, this is the circulation of trade winds. It is also called Walker, Walker, Walker circulation also, because there was a scientist who discovered this, okay, whose name was Walker. So Walker circulation also it is called. So do not get confused. What is Walker circulation? The normal condition in El Nino activities. Okay, in ENSO, normal circulation of the winds. Okay, so the trade winds, or even we also have monsoon wind, right? So monsoon winds also come from somewhere else for till like June, July, August we have this monsoon winds, and after that it goes back somewhere again. Next year it comes. So ENSO or El Nino southern oscillation also is a regular phenomena. Okay, regular phenomena. But El Nino conditions, sometimes because of some other influences in the wind patterns or in the temperature of the earth, we get El Nino frequently sometimes, or sometimes we do not get. Okay, so La Nina is normally a condition when an El Nino takes place. We see the follow-up, okay, of La Nina. Okay, so La Nina is much rarer than El Nino. However, it doesn't mean like, after every El Nino you'll get La Nina. Okay, it is not the correct way to think. But most of the time we have seen La Nina occur after your El Nino. All right, fine. Now you understood the concept from these diagrams. Okay, you understood the concept. Our point of discussion should be, how does it affect globally and in India? Okay, how does this oscillation, okay, what is the impact of this oscillation? Okay, so it is a major driver of interannual climate variability. Okay, when El Nino happens, what happens? We get increased rainfall in parts of Americas, okay, and droughts in Southeast Asia, Australia, and parts of Africa. Okay, El Nino means heavy rainfall in Americas, Peru, Ecuador. Then similarly in La Nina is the opposite, increased rainfall in Southeast Asia and drought in some parts of Americas. Okay, so when there is too much rain in Southeast Asia in December, we also see a lot of big cyclones and typhoons in that area. Okay, fine. And in El Nino case, you can see a lot of cyclones or typhoons, hurricanes in parts of America also. All right. Temperature. When El Nino happens, global temperature tends to increase. And when La Nina happens, global temperature tends to be lower. Why? Because Pacific Ocean is heated up, and because of this heat, we tend to see a higher temperature during El Nino. Tropical cyclones. When El Nino happens, it suppresses Atlantic hurricane activity but increases Pacific hurricane activity. Like I said, when El Nino happens, you'll see hurricanes in Americas. In La Nina, enhances Atlantic hurricane activities. Can anyone tell me where is Atlantic Ocean? Where is Atlantic Ocean? If this is specific, where is Atlantic?
Sir, between North America and Europe.
So this side. Okay, this side. So
Yes,
when,
sir.
right? This side, North America and Europe. This side, Atlantic. Okay. So when La Nina happens, that means La Nina happens means this side is cool. Okay, this side is cool and this side is warm. So you have a lot of hurricanes from this side. Okay, when El Nino happens, this side is cool, this side is warm. So you get a lot of hurricanes in this time, in these areas. Okay, just remember this. Fine. When El Nino happens, it suppresses upwelling. Remember upwelling. What is upwelling? What is upwelling? Upwelling, can anyone tell me? From the picture.
So the rising of cold water to the surface.
Yeah, when cold water comes up, when the warm water or warm surface water goes towards the west during a normal condition, cold water comes up, and along with this cold water, you also have a lot of marine activities like fishes and so many things. Okay, so when El Nino happens, it suppresses this upwelling of cold water. Okay, because of which the fishing industries in Peru and South America gets affected. Okay, they get affected. When La Nina occurs, it boosts marine productivity in this area. Okay, it boosts marine productivity in this area. So La Nina, remember, La Nina is just a normal condition on steroids. Okay, normal conditions on steroid. El Nino, because warm water is still there on the surface, so the fishes, the cold water does not rise, so we don't see fishes on the surface of water. That's why it impacts the fishing activities in the south coast of your Americas. All right, this was global impact. Okay, globally what it does. What about in India? Okay, although it is significant, it is however not exclusive. meaning it does not really influence our southwest monsoon, right? In the world, El Nino is happening, but we do not directly get so much impacted. However, it does cause some problem. It does cause some problem. For example, it might weaken the monsoon winds. So if you remember, southwest monsoon comes from the southwest of India, right? And if El Nino comes, okay, if the air comes, it clashes, okay, it clashes with southwest monsoon. So that is why sometimes we will get less monsoon also, okay. However, it is not directly, you know, very severe as of now, but it depends on the level of your El Nino. If it's very high El Nino, then of course we will have a deficit or drought of in India, particularly in the northwest and your southwest part of the country. We might face a little bit of drought like situation. Okay, fine, okay. So many major Indian droughts like 87, 20, 2002, 2009, 2015 coincided with El Nino events. Okay, coincided with El Nino events. If La Nina happens, what happens? We get stronger monsoon. Okay, we get above average rainfall or very good monsoon in India. Okay, very good monsoon in India. So it often leads to bumper agricultural output and replenishes water resources. So the concept of El Nino and La Nina is very simple. El Nino is regarded with warm air, right? So the temperature, warm means warm and dry air comes in. So because of that, we have clash in the monsoon. Okay, so sometimes it might create a problem in our monsoon, and because of that we might be impacted in our agricultural output. However, La Nina, like I said, it is a steroid form of your normal conditions, right? So because of that, we get good monsoon and bumper agricultural activity. That's what you have to know. Any confusion on this topic? Any confusion on this topic?
Sir, El Nino to হেৰি আমেৰিকাৰ কাৰণে তো ভাল ন sir, South America এইবোৰ কাৰণে
কেলে?
Sir, maybe ভাবিছিলো sir, এছিয়াত যেনেকে আপুনি ক'লে এছিয়াত drought পৰিব, তাৰপিছত তাতে rainfall বেছি হ'ব, অষ্ট্ৰেলিয়াত বেছি rainfall হ'ব বুলি কৈছিল।
That is a normal condition.
আচ্ছা।
El Nino में both sides might face a little bit of problem because El Nino, like I said, it origins during Christmas time, no? So winter time. So in South America, winter time what ki bisare? They don't want rain in winter time. Okay? And it spoils their activity, fishing activities. Okay? So once I send you the document, you read it once, okay? But I hope everyone got the idea. This is a very important topic for this time, geography. Okay, we are facing El Nino right now, because of which our monsoon is slightly being delayed. Okay, so I'm not saying directly that okay, because of El Nino you'll have less monsoon. It is not really, like, you know, true in that sense. But then, like, you know, when El Nino occurs, we do face some delays in monsoon. Okay, we do face some little bit of less rain. Okay, we do see that. All right. So if you relate, not every El Nino leads to drought, and not every La Nina leads to excess rain also. Okay, so it is just an idea that okay, maybe because of this activity we have less rain. Okay, but however, not every El Nino leads to drought, and not every La Nina also leads to excess rain. We have other factors for our monsoon, that is Indian Ocean dipole, which we'll discuss when we'll discuss monsoon. We also have this Maiden-Julian oscillation and Arctic oscillation also influence our monsoon. Okay, so these are some like how Walker oscillation we discuss in this topic, Southern oscillation we discuss. So similarly, many winds are following this oscillation systems. Okay, So because of that, our monsoon is solely not dependent on El Nino or El Nino southern oscillation. All right, southern oscillation. When we have positive Indian Ocean dipole, okay, that is warmer western Indian Ocean, it can sometimes mitigate the negative impact of El Nino on Indian monsoon also. So if our Indian Ocean dipole is strong, okay, it can also minus the negative impact of El Nino on the monsoon. So our monsoon is solely not dependent on El Nino or the activities of El Nino southern oscillation. We also are dependent on other oscillations, so please keep that in mind. Number one is Indian Ocean dipole, Madden-Julian oscillation, and Arctic oscillation. So these are the types of winds that are in circulation, okay, in the world. All right, in the world. Any questions now? Any questions?
লালিনাত হেৰি গোটেই ৱৰ্ল্ডটোকে ছাৰ ফাইদা হয়নে না অকল ছাৰ এছিয়া জেগাটোৱে মানে ফাইদা হয়?
Like you cannot say the whole world in the sense, because it's just a weather weather pattern system, like because of La Nina, yes, some parts of the world will receive heavy rainfall, that is your Australia, in Southeast Asia, okay, excess rain will come there, and then South Americas and Americas, that side, it might be very, very cold, okay, might get colder. All right, so I'm not saying, like I said, if El Nino cannot impact our Indian monsoon directly, we are also dependent on other oscillation. So across the world there are many oscillations, okay, many ocean currents, many types of winds, okay, that are blowing. So yes, on an average, when El Nino is high, we tend to see a rising of temperature all across the globe, okay. We see a little problem in monsoon in India, okay, and then drought like situations in Australia and all those areas, okay. So we might see all that, okay, we might see all that. So discussing all this type of weather patterns or your climate patterns means we have to take in consideration of all the circulation of wind and ocean currents all across the globe, because all of them are interconnected in some way or the other. All right, so this is a condition, actually this is just a condition, that sometimes what happens is when trade winds from east to west do not blow strongly, okay, and they are weakened, we see the temperature rise in Pacific Ocean, okay, the warm water stays there, and because of that we might see a temperature rise in the globe, okay, in the globe, and not much rainfall in Australia, leading to drought, okay, and a lot of rain in the South Americas, leading to floods and cyclones and hurricanes, okay. That is why we read this. How does it impact Indian monsoon? We already discussed. It can delay the Indian monsoon if the El Nino condition is very strong. However, again I mentioned that if our monsoons from the origin, from Indian Ocean dipole, if it's stronger, then El Nino cannot impact the monsoon directly also. Sometimes it just minuses, okay. So everything have to be taken in consideration when we do climate patterns and global patterns. Fine. All right, the next concept of geography is thermal expansion of oceans, okay. Thermal expansion of ocean means increase in the volume of seawater as it warms, okay, as seawater warms, the volume of water also goes up. Did you notice? Okay, how does it happen? First of all, ocean water absorbs heat, okay, and the kinetic energy of the water molecule increases. Kinetic energy, can anyone tell me what is kinetic energy? Kinetic energy, science students, can anyone tell me what is kinetic energy? I'll give you a very simple example. When you take a saucepan of water and then you put it on the stove, right? You put it on the stove. What happens? It bubbles, right? It bubbles and it starts shaking vigorously, right? So that's what happens in the ocean also. When ocean water absorbs heat, the kinetic energy makes it move. Okay, the kinetic energy basically in simple terms means the movement energy. So the water molecules starts moving, okay, and these molecules vibrate more vigorously and they move further apart, meaning the molecules at the molecular level, the molecules are getting away from each other. Okay, because of this getting away, because of this space between molecules, it leads to an increase in water volume without adding any mass. Okay, without adding any mass. However, the density of water decreases. Density means, you know, okay, the thickness, I could say, right? So when this water molecules starts getting heated, so it moves away, and this water molecules moves away from each other, and it increases the volume of water. So if you have observed, when you boil water today, you just boil some water and you'll come to know what happens to the water. Okay, it looks like it is becoming more. All right, so that's what happens in the ocean level. When it is absorbed, heat is absorbed, the water molecules vibrate and it leads to increase in water's volume. That is called thermal expansion of oceans. Okay, that is called thermal expansion of ocean. Now we know oceans absorb over 90% of excess heat. Okay, oceans absorb over 90% of the excess heat in your earth, on your earth. Okay, this is not confined to the surface only, even the entire depth of the ocean, meaning inside the beneath the surface also, it goes, this heat goes and it expands the water. Okay, it expands the water, it gets moved, the kinetic energy starts taking place of water molecules. Okay, fine. Because of the global temperature, we see this thermal expansion. So we have an increased temperature, global temperature have increased. Okay, global ocean temperatures have increased by 1.45 degrees Celsius, and some areas have over 2 degrees Celsius also temperature increase in the global ocean level. Okay, because of that we see a lot of thermal expansion, and because of this thermal expansion we see rise in sea level. Okay, we see rise in sea level. So thermal expansion is a significant and often the largest component of observed global sea level. All right, that is the concept. Fine, that is the concept. So historically, thermal expansion has contributed to approximately 10 to 15 centimeter to global level sea rises. And if this continues, and if even if the greenhouse gases are not or reduced, even if they reduce also, this will continue because oceans are continuing to be warmer and warmer every year, and that will definitely, even if you stop all your cars, vehicles or whatever, it will still increase the sea level. Okay, increase the sea level. Okay, so why it is causing so much problem? Okay, what will happen with this thermal expansion of ocean? First of all, global climate is rising anyways, so that is one of the main reason why the oceans are also warming up. And what is the impact of this warming up of ocean and the expansion of ocean water? First of all, the coastal inundation will take place. Okay, coastal flooding will increase, especially during storms. Okay, so those who are in the coastal areas, they'll suffer majorly. Erosion will take place, okay, in the coastal areas. Then salt water from the oceans and seas will be inside the land, contaminating fresh water and agricultural lands. Okay, and if this continues, salt water, if this continues to come inside land, it can lead to desertification also of some areas. Okay, it can lead to desertification also. This will lead to ecosystem disruption, like coastal wetlands, mangroves, coral reefs will be vulnerable to sea level rise. Okay, many people will be displaced, particularly in the low-lying island nations and coastal areas, and it will lead to severe economic costs. Okay, severe economic costs. That is why it is very important to understand this concept. So I will ask Prince Mehdi to explain me the thermal expansion of oceans.
Sir, যেতিয়া হিটটো হয় তেতিয়া মানে যিটো কাইনেটিক এনাৰ্জি থাকে সেইটো কাৰণে স্যাৰ সি লেভেলটো ইনক্ৰিজ যায়।
No, how does it happen? When kinetic energy takes place, what happens?
স্যার মানে পানীটো স্যার ঘূৰি ঘূৰি ওপৰলৈ আহি যায়, গৰম পানীটো।
Yeah, the water molecules move vigorously. Okay, kinetic energy is not that it's not directly seen. You can only see through the water molecules. Okay, so take a test, take an experiment, do an experiment, boil some water. Okay, on your stove, you'll see what happens to the water. Okay, so that is what increase of volume means when oceans absorb heat, right? So what are the impacts of thermal expansion of oceans? Give me one from each one of you.
Increase sea level.
It increases sea level, fine. Then second impact,
Lead to desertification.
can lead to desertification if salt water, because of rising sea level, salt water goes inside land. All right, what happens to the density of water when thermal expansion happens? Now this is also science.
It increases.
Density of water increases or decreases?
Increases.
ইনক্ৰিজ স্যার।
Are you sure?
Sir,
What happens to the density of water? Harlongbi?
So it will decrease, I guess.
Why it will decrease? Why does density decreases?
So because of the evaporation, I guess.
So when kinetic energy takes place, first the water is like this. If you can see my hand, the water is like this. When kinetic energy takes place, it moves apart the molecules of water. So the density increase or decreased?
decrease.
Yeah, so
Decrease.
density is related to molecules. Okay, if the molecules are tightly packed, that means high density. If the molecules are sparsely packed, that means less density. For example, I'll give you a human example. The density of Guwahati is very, very high, right? But that does not mean only Guwahati has people, no? You go towards Sonapur, you go towards Azara, or further Azara, Rani and all, the density of people are sparse, right? As of now. That does not mean that is not under Guwahati, no? There are so many places that are under Guwahati. So similarly, the water molecules, when heated, it gets separated, okay, from one another. The water volume increases. So when density decreases, volume increases, okay? Okay? But when density increases, volume also decreases, all right? So please keep that in mind, okay? Science students especially should know this. All right, so that was the second concept. The third concept we will do is melting glacier versus melting sea ice. Okay, melting glaciers versus melting sea ice, the third concept. Okay, first of all, what is melting glacier? It refers to the large perennial accumulation of freshwater ice on land. Okay, on land, those are called glaciers. What is melting or what is sea ice? That floats on the sea surface. Okay, that floats on the sea surface. And glaciers are perennial. Sea ice is seasonal. Okay, sea ice is seasonal. So when the water of the ocean froze or freezes and it floats on the sea, that is sea ice. Okay, so glaciers are land based, found in the mountain ranges, all this example. Ocean based ice
Sir.
are, yeah,
Sir, perennial মানে throughout the year হয়ে থাকে নাকি স্যার? মানে
throughout the year. Okay,
ওকে স্যার।
all right. So sea ice refers to ocean base, all right, forms in polar oceans like Arctic Ocean, Southern Ocean around Antarctica. Okay, around Antarctica, meaning because of the temperature sometimes the water freezes. Okay, and because of that it forms sea ice. All right, so composition of glaciers are freshwater. Okay, freshwater. Sea ice is salt water. Okay, sea ice is salt water. However, during freezing the brine, that is the saltiness, is expelled, but still it has salt water. All right, formation, we know how snowfall accumulates. Okay, because of rain or because of water precipitation, we get snowfall on the high mountain ranges. This crystallizes over centuries or over years and years, and then it forms your glaciers. Okay, in the other case, sea ice, when seawater freezes, when temperatures drop below freezing point, that is minus 1.8 degrees Celsius, it becomes sea ice. Okay, volume wise, vast amount of ice. Okay, meaning a freshwater reservoir is there. This is much smaller. Sea ice is much smaller compared to glaciers. They are seasonal. So please know the difference between melting glaciers and sea ice. I'm not saying melting, glaciers versus sea ice. Okay, the difference is very, very simple. One is land based, one is ocean. One is freshwater, the other one is saltwater. One is formed by snowfall and all this, the other because of temperature drop. All right, one is perennial, the other one is seasonal. Okay, fine. All right, so this is the difference between glacier and sea ice. So not all ice that you see on ocean are glaciers. Okay, remember that. So why are we studying this, especially the melting of these two ices? Why are we studying this? Because it impacts directly to your global sea level. Okay, to your global sea level. So when glaciers melt, we see direct sea level rise. Okay, fine. Like for example, Arctic and Antarctica ice sheets and Greenland, if they shrink or if they melt, it will lead to global sea level rise. All right, because these two, Greenland and Antarctic alone, has enough water to raise global sea levels by over 60 meters if they melt completely. Okay, 60 meters means how many feet? Okay, find it out. All right, so it can lead to that. All right, what happens if sea ice melts? No direct sea level rise. Okay, no direct sea level rise. Melting sea ice does not directly contribute to global sea level rise. Okay, because of Archimedes principle. Because what is Archimedes principle? Can anyone tell me? Anyone tell me Archimedes principle? Science student? Archimedes principle? Please read Archimedes principle online or wherever you find it out. So there is this principle. Where? Because sometimes when an object feels lighter, okay, an object feels lighter because of some force, okay, because of some force, all right. So this is what is happening in sea ice. The ice is already floating in the water, okay, it is already floating in the water, meaning it is formed from the water itself. Sea ice happens because of temperature drop, right? So when it melts, the volume is equal, okay, the volume is equal to how much ever volume it has been frozen, okay, to how much ever volume it has been frozen. So that is why we don't see direct sea level rise. Understanding this?
Yes, sir.
So Harlong be understood. Fine. What about the rest?
Yes, sir.
Okay.
Sir, যদি সেইটো কাৰণে নহয় নহলে কি কাৰণে হয়?
Huh?
Sir, আপুনি ক'লে কি ভলিউম যোনটো আইচৰ থাকে আৰু চিৰ যোনটো ভলিউম থাকে ৱাটাৰটো সেইটো যদি একেই হৈ থাকে, স্যাৰ যদি আইচটো যদি মেল্ট হৈ যায় স্যাৰ নহলে সি লেভেল ৰাইজ নহয়, মানে স্যাৰ বুজি নাপালো মানে। নহলে স্যাৰ এটা সি লেভেল ৰাইজ হয় বুলি কৈ আছে আইচ মেল্টিং হোৱাৰ কাৰণে।
Yeah, glacier is formed by extra over the years it has been accumulated and it has been stagnant like that. Glaciers, sea ice is formed seasonal wise, right? Seasonal wise, what is the process of forming sea ice, Prince Rongchang?
1.8 degree minus 1.8 degree যাব লাগে।
Tita pani to ki hai, it becomes frozen, okay. When it goes beyond zero, minus zero, the water on the sea just freezes. Mane gutei giti nohoy underwater, well, it will be liquid, but the surface will just freeze because the temperature dropped. So the volume of this ice that has been formed because of temperature drop is equal to the volume, original volume of water. Hoy na nohoy? তোমাক যদি মই এটা কওঁ এটা গ্লাছটো ফ্ৰিজত থৈ দিয়া, একদম ফ্ৰিজাৰত, 1 glass of water, so it will melt or it will freeze, right? For example, ice cubes, if you put ice cubes in the freezer, it melts, right? It freezes, and then once you melt it, it is the same amount of water that you put in the ice cube tray, is it not?
Yes, sir.
So that is the same principle with sea ice, okay? That is the same principle with sea ice, all right? Sea ice happens seasonally, so that is why there is no direct sea level rise with sea ice, because it's the same water, okay? It is not the extra water that is coming. Glacier, however, when it melts, it adds water, okay? It's add water to the sea, okay? So same, like I said, ice cube, if you keep ice cube, okay, and then you melt it, it will be the same amount of water that you put in the ice tray, right? So that is why we do not see direct sea level rise, but there are environmental and climatic impacts. For example, in melting glaciers, when glaciers melt, okay, the freshwater resources are disrupted. When glaciers melt, freshwater gets disrupted, leading to water
Sir,
scarcity.
glacier melt hole sea level to rise hobo na sir, na nohobo glacier melt hole?
Glacier melt hole to sea level rise hoy, because glacier is a separate ice body. Hey pani khini kot jabo, hey pani khini like extra pani see, the glaciers are already frozen, right? So we have not counted that how much water is there in the glaciers. We do not know how much water will be there. But with sea ice, the same water is been converted into ice. That's why we don't see sea level rise. With glaciers, we do not know how much water is there in that glacier. So when it melts, it adds extra water to the sea. For example, I give you an analogy of your ice trays. Again, I'll give you an analogy. So you bring a glass of water, normal, and you add extra ice cubes into it. So after a few minutes, what will happen? Water will
It
increase,
will overflow. Yes.
yeah, or might overflow the glass. So that is the concept of glaciers. Okay, that is the concept of glaciers. So you are extracting added ice, right? So when glaciers melt, freshwater resources becomes disrupted. Why disrupted? How does it become disrupted?
Because fresh water to melt হৈ কেনে গুচি যায় তাৰপিছত sea water লগত মিলি যায় and fresh water becomes salty water, so there is less fresh water.
Yeah, one way is that. So in the Himalayas or in the mountain ranges, if glaciers melt, then it is a problem for the communities up there. Okay, it can be a problem. Okay, and it can be problem to many cities also if glaciers keep melting. Glaciers, when they melt, can cause glacial lake outbursts, floods. Rapid melting can form large unstable lakes on top of the mountains. And if these lakes burst, then what happens? It causes floods downstream. For example, Kedarnath, right? There is a lake in Tawang, okay, and scientists have said that it towards Tawang that this lake is melting, okay, and if it melts completely, the water will go where? It will come down only downstream to other parts of Arunachal and Assam, so it will flood downstream. Okay, so those are called glacial lake outburst floods. Okay, fine. That will lead to ecosystem disruption, that will change the flow of rivers, okay, and the temperature also will be affected. It will also be albedo effect. Albedo effect means retreating glaciers expose darker land or ocean, right? This ice, okay, this ice reflects back the sun rays, okay. This ice, particularly the glaciers, are responsible to reflect the lights, okay, that is coming from sun. So if this melts, the earth will absorb more heat, the ocean water will absorb more heat, okay. That is albedo effect, okay. That is albedo that is reducing the albedo effect. Albedo effect means the reflecting back of sun rays, okay. Okay, fine. So that will lead, if this glaciers melt, that will lead to further warming of the land and your oceans. Then it will cause permafrost thaw, okay. So the glacial retreat can expose permafrost, so the ice that were permanent, they will also start to melt, and they will release gases like methane. So when ice also melts, it releases gases, greenhouse gases like methane, okay. Have you seen in ice cube? You just take out the ice cube, you see some gases going out, right? So sometimes because of the mix of the earth and all those, it will release some gases, greenhouse gases like methane. In regarding sea ice, when ocean ice melts or sea ice melts, the albedo effect, okay, the albedo effect, okay, it's melting exposes again darker ocean water, which will absorb more solar radiation, leading to further warming of Arctic region. Okay, fine. Same thing. Ocean circulation will change. Changes in sea ice extent and freshwater input can alter ocean currents. Okay, when this ice melts, it will change the ocean currents, impacting global weather patterns. All right, impacting global water patterns. Ecosystem disruption also there when sea ice is melted, because this sea ice acts as a critical habitat for polar bears, seals, and various marine organisms also. Okay, and it will open up new sea routes if the melting takes place. It will open up new sea routes, particularly your northern sea road that is we are seeing in Arctic Circle. All right, and because of the permafrost thaw, this can expose coastal areas to warm ocean areas, again releasing greenhouse gases. So both of these ice are important for our concept in studying sea level increase. Both of them are important. Okay, both of them are very, very important in our climate pattern, understanding of climate pattern, right? Only difference is sea ice can be seasonal, while as glaciers are permanent. Okay, fine. Any confusion with this concept?
No, sir.
Oh, sir.
Okay, so if you quickly go through APSC 2024 question, there was not mention of sea level or sea increase. Okay, we got ocean currents, okay, but we did not get any question on sea level rise. So please go through this time. It is quite important, sea level rise and all. Okay, quite important. So we don't see here also. Okay, fine. That is one important concept that you have to do. Melting ice. The next important and the last one for today, probably, yeah, last one, is eustatic sea level. Eustatic sea level. Okay, please read this quickly. Eustatic means global average sea level rise. Okay, eustatic sea level refers to the global average sea level. Okay, that is changes in total volume of water in the oceans. Okay, changes in the total volume of water in the oceans. There are two main ways which can cause sea level to rise. Okay, the eustatic, just remember, it is global average. Okay, eustatic means global average. So it can be increased by two mechanisms. One is when there is changes in ocean water volume. The one reason for increasing ocean water volume is thermal expansion that we have already studied, right? Then when glaciers also melt, that also we have studied. Okay, fine. That is one way. Changes in water volume. Okay, how water volume changes? Either by thermal expansion or when the glaciers melt or ice sheets melt, that we have already discussed in the previous topic, right? The second mechanism is when the volume of ocean basins take place. Ocean basins take place. How does it take place? First of all is mid-oceanic ridge activity. Mid-oceanic ridge activity, can anyone tell me what is mid-ocean ridge? Do you know? In
Spreading
ocean.
of oceanic flow.
Yeah, Roshika?
So it's like a mountain inside the ocean.
Spreading ocean flows.
Yeah, spreading of ocean floors and it forms mountain, right? So for example, you take a bucket, okay, you take a bucket of water and you put stones inside the bucket. What will happen to the water? Do you know that story? The crow.
So water level will rise.
Yeah, that story is there, no? The crow keeps putting stone after stone after stone in a pot, and then the water comes up and it drinks the water and goes, right? So that is the same thing in mid ocean ridge. Okay, mid oceanic ridge activity means when the sea floor of the ocean rises or expands, what happens to the water level? It goes up. Okay, it goes up. Okay, that is what is one way. So when ocean basin increases, that is by mid-oceanic ridge activity, the water volume increases. And when the ocean has a lot of sediment accumulation, okay, sediment means sand, bali, whatever, right? So it can also lead to the change of volume of water, all right, and lead to increase in sea level, okay, lead to increase in sea level, okay.
So what can lead to ocean basin?
Uh-huh.
So what can lead to like rise of ocean basin, like
Push in basin.
sir basin যে আপুনি ক'লে অলপ আগতে
Uh,
মানে সেডিমেন্টেশন আগত যে আপুনি স্যার বেসিন বুলি ক'লে এইটো
Yeah,
কি কাৰণে হ'ব পাৰে?
mid-oceanic ridge happens maybe because of tsunami or underwater tectonic movement. Okay, then earthquake underwater or tectonic plates changing. Okay, so the second reason for increasing volume of water in sea, that is by tectonic movement or your sediment accumulation, it can take some time. It does not happen very quickly. But however, the sea level rises because of your what do you call it, thermal expansion and all those are very, very quick. Okay, it happens very, very quickly. Fine. Fine. So what is the difference between eustatic and relative sea level rise? Okay, eustatic means global average. Okay, total ocean water volume is increasing. Okay, that is eustatic. Relative means local. Okay, in certain areas only. Okay, when sea level rises, for example, on the coast of Mumbai, if it increases and the rest of the world is not saying any increase, that is just local sea level rise, right? Just local sea level rise. How does eustatic sea level happens? Because of thermal expansion, because of melting of glaciers, because of ocean basin volume changes. We already understood, either by mid-ridge ocean activity or your sediment accumulation. Relative sea level increase happens. Yes, it happens because of eustatic changes plus local land. Okay, local land also. Okay, influenced by local land. All right. Fine. So this is a global average. Eustatic is global average. Relative is local measurements. So sometimes in the coast of Mumbai, you'll see high sea tides. Okay, a lot of water because of tides and all those. Okay, it happens locally also. It continuously happen at night. You know, when there is full moon, you'll see the tides up and down. Okay, so that is local. But eustatic means overall ocean of the world volume increasing. Okay, impact of eustatic global climate patterns. Okay, or that can lead to coastal inundation or destruction. Impact of relative sea level, it's just specific coastal areas only flooding in some areas and destruction in some areas only. Fine. You understood what is eustatic and relative sea level, right? Relative sea level is local level. Okay, sometimes because of high tides, low tides, we see some water going inside some areas, and then again it reduces. However, eustatic means the global ocean. No matter how many oceans we have or seas we have in the world, if all of their water increases, that is eustatic. Okay, that is eustatic. Fine. Okay.
Yes, sir.
All right. So we will stop here. We discussed 4 important concepts regarding your examination. Please go through these topics and try to solve questions. You put this document in your AI and try to ask, like, you know, frame some questions on this document. Okay, so please solve this on your own. Okay, these are very, very important concepts. First of all, you just go through El Nino again. If you don't understand, okay, if you don't understand, there is a simple video. Okay, there is a simple video by this teacher called Amit Sengupta. He mentioned about this El Nino like 6-7 years back on YouTube. He's a UPSC teacher, Amit Sengupta. So please go through his videos. Very, very helpful. And some people say his voice is very soothing to listen to. So if you don't like my voice to, you know, to listen to, you can watch his videos also. He'll explain the same thing I explain, but he explains it very simply. Okay, not all information will be there. Information you can take my notes, but you can watch his videos. Amit Sengupta. Okay, go through that person also. So we will stop here. All the 4 important topics. Please go through that. Tomorrow we'll come up with some more topics. Okay, important ones. And please do your previous year's questions also. Okay, if you don't have I hope you got all the subject details, right? Did you all get the
Yes,
subjects? Yeah, my that analysis every year. So go through that geography section and just mark the important topics and just go through that topic. Like, all the topics of the past year papers, just read once. You never know. All of a sudden, you might get a common question also. So just for your own safety, just go through the the subject analysis and read the topics. Okay, types of ocean current, types of warm ocean current and cold ocean current. So you just mark it down. Tomorrow we'll come up with maybe some important places in news and other concepts that we need to cover, particularly regarding your Indian monsoon. We'll discuss all those topics tomorrow. Okay, so I'll see you, the few of you, in the afternoon.
Sir, হেৰি আপুনি আসাম নোটছবোৰৰ পৰা হেৰি এনেকে কৰিম নেকি স্যাৰ কি নোটছবোৰ এআইক সেন্ড কৰি দিম তাৰপিছত এনেকে কোৱেশ্চনছ ফ্ৰেম কৰিব দিম এনেকে সলভ কৰি থাকে নেকি স্যাৰ
Yeah, you can if you have the time, right? If you have already studied Assam base and you're just like, want to practice some questions, you can do that, no problem. Okay, no problem at all. However, like, just go through the past year question papers. How are they asking the questions? Okay, so once you understand the idea, then only you do the questions. Iman tan nahe Assam base.
স্যাৰ এবাৰ এনেও দিব নোৱাৰো মই
No, does not matter. Okay, it will not be very hard also. No worries. But just go through the question patterns. Don't just keep solving ahoms, and you don't get one question also from ahoms. It will be such a waste of time. No? So just importance I'll tell in the class only. What are important, I'll tell. Okay. So I'll see you later.
Thank you, sir.
Okay. So.
Thank you, sir.
Thank you, sir.
Bye bye.
Thank you, sir.